Hello, and welcome to this webinar. I'm going to be talking about RavenDB. It's all the rage right now to talk about AI and all of those sort of things. But before we get to that, I want to talk about going from the basic up. Don't worry, we're going to cover some of the nicest features of RavenDB along the way, and we're going to look at some of the really cool stuff with AI in the app. So let's look and start from the get-go. RavenDB is a document database. It mostly deals with JSON documents. It can also deal with binary data, time series, etc. The primary reason RavenDB exists was my personal frustration about how complicated it is to actually get stuff done with the database. You might be familiar with the DBA saying, no, I cannot do that. Or the developer saying, hey, this is really complicated. I don't know how to do this properly. Or it's going to take a lot of time. Or the database is typically not something that enables you to do stuff. It's something that blocks you from doing things properly, from changing, etc. So the whole point of RavenDB is that we want to have a database that absolutely gets out of your way. This is what we created for. So now let's talk about what we have here. I created a sample application specifically for this demo. For some context, I made, I think, quite a few in Microsoft Ignite, and I got the idea from some of the conversation that we had there, and we have this idea of a property management application. The whole idea is that we're supposed to manage rental properties across locations, and we have things like leases, rental, service request, a whole bunch of other stuff like that. So this is the actual application, and you can see that we currently have 3 properties. And I can do things like this, and we get spatial filtering based on what we actually see in the map. And I really like the way that it works. You can see that the user interface is quite nice, but honestly, this is not the point of this conversation. We're not going to talk about how to build good UI. This is really not my cup of tea. No, what I'm going to be talking about are how do you actually build such an application successfully and still be able to process complicated changes over time, evolve your application, handle load and complexity that only keeps growing. So let's talk about the simplest scenario. What we have here is processing a service request, like I have a problem with my toilet, or the door doesn't lock, or stuff like that. And this is a great example of how you can insert data into RavenDB. And here we have the relevant code, this guy right here. And what you can see is that we have a session. In this case, this session was created in the constructor. And the usual MVC, dependency injection, etc. I'm going to assume that you're familiar with how code works, and we can only focus on what RavenDB does that is unique to what we do. And honestly, we're not really doing that something that interesting here. We get the service request as a body, we set some values, and we said that that is a nothing burger. And that is very much by design, because we do not want to have stuff that is surprising. We want to have stuff that is predictable, that is boring, that allows me to just get things done. So now, let's look at something slightly more interesting. Now I need to update a service request. And I want you to take a look at this code and notice some really interesting things. We load the service request by ID, and the relevant code is right here. We load it, we modify it, then we call save changes. I want you to pay attention to the code that is not here. Previously, we had to call store. We do not have to do it now. Why is that? Because we loaded the entity, the service request entity, through the session. So the session actually keeps track of that. It handled change tracking, it handled unit of work, a whole bunch of other patterns. The core aspect here is that you do not have to deal with any such details. You can just run with that. Now, let's up the complexity just one tiny bit and look at how we can terminate a list. So let's see what we're doing here. Given a list ID, by the way, I should probably show you what the documents look. So here is the document in question. And you can see previously we looked at service request. And here is my leaky faucet or leaking kitchen sink. And here we have a list. And the list belongs to this renter. And it is associated with this unit ID. And now you can see here, I'm loading a list and I'm saying I want you to include also the unit ID. What does this mean? Let's take a look and see. This is as expected. Here are the result, and we're doing a query and not really that interesting. Now, you can see something really interesting. We got another tab here. And this tab is meant for you to look at, here is this guy. It is. So the idea here is that RavenDB, using this include keyword, allow me to reduce the number of server round trips that I have. Take a look at this. What about these guys? I can do it like this. So now in a single round trip to the database, I can load the entire thing in one shot. And here you can see how it looks from the perspective of the client API. The killer thing from our perspective, this does not call to the server. We already loaded it here when we use the include. And now again, I modify the list, I modify the unit, and I call save changes. And I have one call to the server, I have another call to save the changes, and both of those values are going to be saved in a transaction with all of the usual mechanics of that, atomic, consistent, isolated, durable, ACID, etc. So this is really cool. And again, I'm showing you a lot of code that is just not there. Now, let's look at something slightly more complicated than this. Now we have a payment. And in order to understand a payment, we have to look at the structure. So let's look at this payment. And you can see that we have one payment for a total of for 1,500. And it's composed of two separate payments made by two separate people, each one for half the rent. So because this is a complex structure, let's see how we deal with that. The first thing that we do, we run this weird query. What this say is I want you to find all of the depth items that are inside the payment allocation, which is an array, and then give me all of the depth items. This goes to the server once to load all of this data. And now I can run over this and notice that I'm loading each one of those. And this does not go to the server because I already preloaded that. And then I modify this. This already stored, and everything is being saved in a single transaction to the database. All of this code results in two remote calls. That's it. Okay, awesome. Now, let's talk about queries. And what we can see here is a pretty simple query. Here is we're using LINQ, and you can see here what it does. And now here you see something a lot more interesting. This is the RQL that we generate. Let's go and look at the code. And this is for leases. Here we go. So here's by unit ID, and you can see what the code looks like. Now, I'm going to do something pretty cool. I'm going to go to RavenDB, manage server, traffic watch. And then I'm going to watch what queries are being generated when I run the application. So here's the application. And I go and I look at those. And we'll see exactly what's going on in a bit. What we can see here is here we're querying for leases. And we should be able to do it like this. You can see the actual query that was generated. You can also click here and actually run the query, and you can see that this is when you look at this guy. Sorry. This is when you go here and you need to get the active list here. So now, this is a really nice feature that allows me to understand exactly what my system is doing. You can also see how we can directly translate from the LINQ query, which is strongly typed, checked by compiler, all of those, all the way to the RQL that we generate and what is actually being sent to the database. Now, let's up the difficulty just a little bit and show you something a lot more complex. This is how we can select the status of service requests. This already requires something a lot more. Let's look at this code. Here we have a query. And this is an interesting query where before, in here, for example, I just query on list. In here, this is much more complicated. What's going on? So let's talk about indexes for a bit. Here is an index. This is an auto index. This was created by RavenDB. And you can see that we have a bunch of fields that we index. This is the index that is used for this. And there is another query that checked by list's parental ID. So RavenDB merged all of those queries together into a single index that can serve all of those results. This is actually really cool when you think about it, because I didn't have to write any indexes. It's the responsibility of RavenDB itself to monitor my queries, generate the property indexes, and manage everything for me. Now, in this case, this is weird. We're not querying on service request here. We're querying on something very different. What we have here, this is an index creation task. So this is how you can create a RavenDB index yourself from code. And the idea here is that we have this map operation. And this map operation run over all of the service requests and project all of the fields that I want to filter on. In particular, you can see that this allows me to also index values that are coming from a different entity. So now we are looking at the service request, and we can see that in one shot. Here's a service request. And this service request is associated with this property. So I can go here and look at this property, and here the latitude and longitude of this location. So what am I doing here? I'm saying I want to be able to search for service requests using Spatial Queries. In order to be able to do that, I need to know which property it's associated with that, because that's where I actually have the GPS locations. So I can do indexing, associate this location with this service request. And now, when you look at this code, look at the recent, I'm zooming in, and this is being filtered. And now this is being filtered. And this is exactly how it works. Because now I'm able to look at this and filter by location. You can actually see it really nicely here. When I'm saying, okay, here is, I need it in open status, I need it the latest. And then we have the query using Spatial. Then we have this thing that looks kind of scary. Let's analyze it in a little bit of that. So this and this are exactly the same. And you can see that here is the query by a named index. Now, this is the status that I have, and this is how I do a spatial query in RavenDB. Let's go and look at the actual results here. Second. And here are the service requests. No, sorry, this is weird. Here we go. So now, take a look at what we have here. Here is the actual query. Here is the spatial query. And here you can see that we draw a polygon. And this allows me to actually see what's going on. I can also do this, I hope. And you can see this is for closed, open, etc. Not really that interesting. But this is the polygon that allows me to look at where I am, what I'm doing, etc. So this match what we're seeing here on the screen. Now, this is ordered by, it's not really that interesting. This is where it gets really interesting, because I want you to look at the last two properties. Property name and unit number do not exist on the service request. They exist on related documents, which we are then able to load during a query. You can think about these load statements or these stored queries here like a join. But this join isn't actually intended to be a It's not actually something that you have to worry about Cartesian products and cost of that, etc. This is actually applied at the end of the process after we run through all of those steps. So you only operate on the set of values that are actually bring to the table. So this is really cheap and doesn't modify the structure of your actual data. Now, oh, by the way, notice that in this case, when we talk about related documents, we have two levels of that. Here, this location is the location that we bought from the property. And then during the projection, we load the unit document and we load the property document to get the relevant properties from them. So we have a very high degree of freedom in how we operate. Now, this is how I load the associated document. And this is now a new index. This is the depth item index, which you can see here. Now, here you can see I'm loading the related property. And again, I want to use Spatial Queries here. So I have to load the related document so I'm able to run the Spatial Query. And now I'm doing something really, really interesting. I'm doing a computation. I'm checking how much money I still have to pay for this particular depth item. Why am I doing that? Why shouldn't I just do that during the query? You know, I can run a query like this. Is it? Why not just run the query like that? The answer is because of what I would have to do in order to answer this query. This query requires me to compare these two fields, which means that I have to actually go ahead and scan through the entire list in order to do that. Instead, because I have this amount outstanding, I can do it like this. Outstanding. Okay. So now I can see that here is a due. Here I pay a little bit, but not all of that, etc. Whereas if I'm using this, all of them are properly paid, etc. The difference between this and this is that during indexing, I already did this computation. So I don't have to do any complicated interactions. You can actually go here and look at the raw index entries that we have here. And you will see that we have a new amount outstanding here, which is an artificial, a computed field that we generated. And that means that I don't have to do any computation. That is actually a significant savings, especially if you have a lot of data. And everything in RavenDB is meant to keep operating while you run with a stupendous amount of data and without you really having to think about it. A lot of that is about how you should be doing stuff. Now, if I were to try something like this, I cannot do this. We cannot compare one field to the next. I can do this. And this is really interesting. So I cannot do this using a filter. I can do that. I cannot run this using a where. I can do that using a filter. Filter is basically saying, oh, I want to scan. I want to go over everything and pay this cost. Typically, if this is a one-time operation or something like that. But for the most part, I want to use a where. I want to use this trick to do computation once during the indexing, and then I can access that very, very. Now, let's talk about data that is more complicated. We already saw a little bit with payments, and I think that we had a more complex payment here. So here you have an object, a payment object that contains multiple arrays and complicated objects and something like that. Obviously, this being a very simple sample application, we still have relatively simplistic model, but you can already see how doing something like this in a relational database, for example, would require many different tables, especially if the format of each one of those was even slightly different. Then you have a lot of table and many joins and really a high degree of complexity. Another aspect is we can go here and we can go here. And now you can see that in addition to the raw data that we have about the unit, we also have here some time series information. So this is how much kilowatt hour I used here. This is how many gallons of water I use in every hour. I can also start doing some aggregation of that, and you can see that I'm pretty started low, started using more, and this is more or less the new normal. This is what you see when you go deep here, and this is the end result of this. Both this and this are coming from this time series information. And in fact, the whole idea with time series as a dedicated data type instead of RavenDB is this notion that I have the ability to store a lot of data, a lot of time series data, some value that change over time, such as the kilowatt hours, the gallon that I'm using, etc., in a very efficient manner without taking note of disk space, computation power, etc. Here you can see how I can query that, both in C# as an RQL, RavenDB query language. And you can see it's pretty easy. I'm saying, oh, I'm running over this particular unit, and I want to do a projection of all of the time series data by 1 hour, and all of the water area in this data range per hour, and that's about it. That's all I need to do. The nice thing about this is that if we go back and look at the actual unit that we have here, you can see we have a not insignificant amount of data. And still RavenDB is able to take that and aggregate that. We can also do that if we had hundreds of millions of records. This would still allow us to run in a highly efficient manner. Okay, so now this was just to give you some idea about how RavenDB works and a little bit of a taste of some of the things that we do. I have to talk about AI because this is expected, and I decided to build a bot in Telegram that will allow me to do things. So right now I'm this renter, Chondo, and this is my Telegram chat ID. And I'm going to ask a question, and hopefully I'm going to get an answer. I even got what looks to be the appropriate answer. Okay, and some additional follow-ups here. And here is the result. Who is my roommate? Okay. So you can see that we get some really nice interactions. But how exactly does this happen? How exactly does this work? RavenDB has the notion of an AI agent. This AI agent, in this case, this is the property management assistant. You can see here the answer to my query. Here are the likely follow-ups, and you can see the actual follow-ups here. And here are some details that we have about how to scope the agent and how it works, and a whole bunch of tools that we can use to use it. Let's dig a little bit deeper, and you should be able to see that we have here the property agent. And as you can see, this is just the code for what we're seeing here. We have the system prompt definition of the agent, which connection string it uses, and this is already much more interesting. We have to pass the current date because otherwise the model doesn't know at what time are we talking about. I think it's something in 2024. Then those are stuff that we are not sending to the model, but we use them to scope the answers to that the model is using. Let's look into this. So we have this renter ID, and we have this notion of a query. In particular, give me all the data about a renter by ID based on the renter ID that I have. Let's go and look behind the scene into what we have. Here is this document. This is how RavenDB maintained the memory of the agent. And now we can see that on startup, I run this query, which gave me these results. So now the model has more information about what I can do. And when I ask this, it's very fast to answer that because it already knows. And in this case, when we define this query, I said, oh, I don't want you to allow the model to explicitly query that. I want you to be part of the initial context that I sent to the model the first time we start a new conversation. And then the next thing that I did is current rent amount. And now it uses the get active leases. This guy. And this is what this looks like. Both of those are parameters that have been defined by the agent. So it has no control over that. You can see that here I have no control over this. And then who is my roommate? Her name is Jen Smith. And the reason I get that is because I have this. So in the end, I have John Doe. This is me currently and Jane Smith. So far, so good. Now, let's look slightly deeper. Here we have the get utility usage. So let's ask about it. How much water did I use the last 3 weeks? And the model is going to think about that. It's going to utilize the capabilities that we give it, and it's going to answer the question. And again, now we can refresh this. We can see what it actually did. So the end date and the start date are being defined by the model, while the renter units, which are the relevant units that we have for this, are controlled by the agent itself, by the scope. So I cannot get the model to say, oh, I want to look at property 2 or property 5 or something like that. It's just literally not possible for the model to do so. By the way, let's run this query, and you can see how in one shot I'm able to do really interesting results. It's not really meaningful. This is just sample data, but I really like it. Now notice that this is basically just another way of doing this. But, I can actually get the model to do stuff here that is easier, cheaper, etc. So I can say, in what days of the week do I use the most electricity? Which doesn't seem like that much interest. But think about it. If you want to ask something like that and you want to have a report or something like that, this is work. Now, just because that information was exposed to us, we now have the ability to look into that and understand this. Do something slightly more, but I notice that it keeps using the last 3 weeks as its context. Now I can go here. And again, let's go to the memory of what we have. Sorry. And now this is a much more complex query. But as frightening as it is, and we have lots of text here, it's pretty simple. All of the leases where I'm renting in that are still valid, and then load the related documents as part of the query. So load the unit, the property, and the related renters, and give them all back. Simple as that. That's the point of what we're trying to do, to make things as easy as possible. So we have a really nice way of asking about what's going on with my lease and what's going on with everything else. Now, let's do something more complicated. I'm going to ask about a leaky faucet. And I have an open service request. Let's look into that. That's interesting. Here is the relevant service request. It's leaking. How did it know? Well, let's go and find out. I don't have to guess. I can just go and look. So when I did that, it will RavenDB run this following query. So give me the results of leaking and faucet, etc. And the way that it works is that this uses a vector search. So the more closely I am related to this, it's fine. We can even remove the leaking, and we still get a faucet. Because faucet and kitchen are relatively close together in vector space. So that's something that I really love, because what we ended up having here is the AI model was exposed a tool that itself uses an AI model. So we're now able to not have, I have to remember this was the kitchen sink and not the, leaky faucet or stuff like that. That makes things a lot easier and nicer to deal with. Okay. So now, here we go. Renter is an agent scope parameter. Let's see what happened when I run this. How much money do I owe you? And we're going to get an answer. Okay. So I want to pay, and notice something. I have to put some attention to this. Look, this is the agent definition. It's less than 200 lines of code. That's it. We also have here the Telegram polling service, which I will touch in just a little bit. And that is a lot more code. And all of that is to deal with stuff like this. So I'm sending a message and I have to, that's about it. Which is utterly ridiculous if you think about it. A lot of this code is just, basic error handling, etc. So now I'm able to get some really sophisticated answer here. And to be clear, I'm using a model that you can use too. This is just OpenAI using GPT-4.1 mini. So this is actually a really important aspect because RavenDB being able to actually run on the mini edition proves something really interesting. You don't need a PhD level AI stuff. You can use the really silly stuff as well. For example, let's use the Nano edition. So make it somewhat dumb. Now, let's ask it, my door doesn't lock. So again, we switch from using the GPT-4.1 mini to GPT-4.1 Nano, which is less capable, and it is much, much cheaper. What just happened? That's actually interesting. Let's see what happened. Here we have a service request. And you can see that it filled up everything for me. And let's look at the conversation and see what happened. So the door doesn't lock, and it called to create service request. What just happened here? How did it went from, I see this to this? In order to understand that, we have to understand how RavenDB works, how agents in RavenDB works. We have this notion of a property agent, and we expose both queries like this and actions like this to the agent, and the agent may call that. And what you can see here is that it provides some information about how do you do stuff. Oh, if you want to create a service request, you need to send me this guy. And this is the meaning of the parameter, etc. Now, agent is like a class definition. And there's a whole bunch of code here that is mostly about dealing with Telegram bot. This is the stuff that we really care about. You can see that we have a process message, and here is the chat ID and the message text that we have. I go from the chat ID to the renter in question using this, check if I don't have this, and then I get the conversation ID. This is the idea of the conversation of this particular user with the model. And as long as you have the same conversation ID, you have continuity. So in this case, the way that I use that is the chat ID and today. So each day you will have a new conversation automatic. This delete the conversation if I want to do that. And now we get to the right part. We have the renter because we know it from the Telegram chat ID. We get all of the units that belong, all of the units that this renter has a list for, and then we create a conversation. This conversation is similar to an instance of an object where the agent is the class definition and the conversation is the instance. And we create that with the renter units that this applies to, and the current date. As a reminder, those two are not being sent to the model, but this one does. And we control them using the send to model option. And now we register handlers for charging the card, for creating a service request. And this is what actually happened. When I told GPT Nano that my door doesn't lock, it decided to call the create service request, which means that then it went into my code, my authorization, my validation, the whole thing is my stuff. And then I'm done. Notice that this is the whole code that I have to write. It's not a lot. And now I set the prompt, which is the text that the user sent me. And then all of this is just to be able to do proper streaming with the Telegram API, which kind of sucks, but I wanted to have this nice typewriter effect that we have. I want to pay my my dues. How can I do that? Now again, I hope that you saw that it streamed as it goes along. So this is the major cost of complications here. I could write it in a much more simpler fashion without that. There's also, all of those things, etc. And I want to pay using this card. And then it's going to think about it. And it's going to say, okay. And what it end up actually doing, it end up calling this code, charge card, which end up going here. And this is just, the usual semantics for this basically generate the load the relevant items, run over them, set up the amounts that we are due, and a whole bunch of other stuff like that. This is the mechanics, the minutia of how you actually charge. What is interesting is that this is the code that I had to write to integrate my payment service into the Telegram bot and the AI, etc. So I get to use all of my existing code, all of my existing validation, authorization, business rule, all of that. I don't have to invent the wheel. So we actually saw quite a few capabilities that we have here, but we're not done yet. But we can go into the back end and see what happened. Pay with blah, blah, blah. I can do that. Now I can also say, I want to pay upfront, and let's see, how about this? This is not my card. I cannot pay with that. By the way, even if it was my card, I would then go here. If I was able to trick the model to do that, I would go here, and then at some point it would error. I remember writing the code for that. I don't remember what it is. Let's see. This is the card. Oh, it's where I'm calling. Here I'm validating that this is my card. If this is wrong, then it will throw an exception. And let's say that if card, let's do it like this. I'm running blah, blah, blah. Now let's see what happens. It's going to try to charge. It's going to fail. What was the problem? Okay. So you tell me, hey, there is a problem. I didn't give it a lot of information. Stuck to it. Let's see what actually happened behind the scenes. Remember, this capability of you to be able to look and see the entire interaction with the model is super interesting. By the way, this is weird. This is not what I expected to run. Let's try it again. Now again, I can see what's going on. Now it's trying to charge, and apparently we get the wrong error here. But at least even if we get the wrong error, we still get good results from the overall process. So now, let's do something nice. I'm going to keep complaining, and I just sent it an ugly picture. What just happened? I want you to take a look into this and understand what I just did. Because frankly, I wrote this demo, and then I was super happy with myself about it. We have a system that is able to look into things and make a lot of really interesting behaviors. So let's see what actually happened. I have here this image. And remember that I told you that RavenDB can store images as well, or attachments as well. Here is an attachment. Here is the description of the attachment. Where did this came from? I defined an AI task. And I actually define it in code, and we can see it right here. So here is the describe photo task. It's going to run over the photos collection. It's going to run this if I have an attachment called image JPEG. Here is the instruction of what to do. And here's how I want to get the data out. And then I want to copy the description back to the model. So what actually ended up happening is that here we have a process attached, a process photo. We're getting the actual image. We download the file. And then we store any document and the actual stream that we got, this memory stream that we got, back into RavenDB. And then this particular task is going to wake up and go and talk to the model to ask it to describe the image. So we have this guy. On the other side, we have a notion of a subscription. Here, this is a subscription where we have a description. We also get the related rent already because of this. A subscription is a way for RavenDB to continuously monitor what's going on in your system. So in this case, I said, I have a subscription on after photo analysis that run over the description. And then it is the responsibility of RavenDB to call me. And you can see I actually have a live connection, right? So I can go here, and this is how I define this. I set up a subscription worker, and then I call run on all of these patches. And then RavenDB, whenever there are new documents that match the query of this subscription, would run this code. And when RavenDB run this code, it's going to say, here is the related renter. Let's send this message from the model, which is the caption that the user sent and the description that we generate from the model, back to us. And again, we're going to look at the back end of how things work. And here we go. This is payment process, blah, blah, blah. And the next statement we have as far as the model is concerned is that I uploaded the image with the caption, and here's the image description. And then the model is able to take this and create a new service request, etc. This is it. As I mentioned, most of the complication in this code is the fact that I have to deal with the Telegram API. And even so, we're talking about 400 lines of code. The actual property agent, less than 200. Okay, so we already talked about this, how I can load related documents and how I can do really complicated stuff. But I noticed that this is how the model is able to figure out who is my roommate, because I already gave that information. Now, who used all the money for hot waters? And we actually saw that when we ran the, on Wednesday, I had somewhere around here. Here we go. And we saw this. Now, if you have any questions, now would be an amazing time to ask them. You can use the chat, or you can just use the chat. That would be the easiest thing for me to answer. And there's also the Q&A if you really want to. And just to recap, we have here a sample application. This sample application is able to do spatial queries, able to look into really complicated model, see how things are working. Here I can mark this, progress, whatever. Drill down and see exactly how things are going, show really rich interface, and the end result, the code that we write, is simple, it's performance, it's obvious, it's robust. It's robust from errors in the backend, it's robust from having me to change that over time. You can actually see that a lot of the indexes that I wrote here are actually auto indexes that I need to do in order to do a whole bunch of stuff. We actually have quite a few manually rolled indexes, because RavenDB is smart enough to know how to do the appropriate thing. And we're using features such as a vector search, such as a spatial search, and I don't feel this weight that I have on my head. Now, this is a sample application. You can go and look at it right now. It's in the samples property, in the GitHub samples property. I'm going to throw that on the chat right now, so you'll be able to see that. And if you have any additional questions or any other stuff that you'd like to know, feel free to ping me. And thank you. Thank you very much. And I hope that you had a great Microsoft Ignite. And I hope that this was interesting. Thank you. Goodbye.